So what I really like about this technique is that if you need to go back and re-listen to a certain question, you can at doing any time. So take advantage of the technology that you have. So for our next question, we're going to arrange decimal numbers from least to greatest. Okay, so let's write down the question first. How to arrange decimal numbers from least to greatest. To greatest. We're going to make that red because occasionally you might see greatest to least. So know what you're being asked. Okay, so for example, just throw you some numbers here. You have 5.49, 5.026, 5.31, and 5.2. If you want to pause this video and try it yourself first, you may. Otherwise, let's take a look at how we can figure this out. Okay, so the technique is basically two steps. The first step is to put in zeros. Write this down so that you remember. Until, okay, put in zeros until all of your numbers have the same number of digits after the decimal. Have the same number of digits. I misspelled digits, right? Try this again. After the decimal. Okay, so the first one is 5.49. Okay, the second number is 5.026. Okay, let's write this all down first before we add in the zeros. So 5.31 and then 5.2. Okay, as you can see, I lined up all my decimals. Okay, so that way we can see which of these numbers have the most digits here. Okay, as you can see, it's the second one, right? 5.026. So I'm going to add in a 0 to my first number so that it will balance. Add in a 0 to the second number, rather instead of balance, I should say, until they all have the same number of digits. Okay, so here I'm going to add in two digits, two zeros, so that they all have three numbers after the decimal, right? 3 digits after the decimal. Okay, so now you can put these in order. Okay, since the ones place is all the same, I'm going to look at all these place values to the right of the decimal here. So see which of these is the smallest. Okay, so as you can see here, we have 26, and then you have 200, and then you have 310 and 490. That is how you're going to put these four numbers in order from least to greatest. Okay, so now step 2, you can put them in order. In order. Okay, so the first one, the smallest one, is 5.026. Okay, followed by 5.200. Actually, the original question only gave me 5.2. So that's what I'm going to leave it as, okay? And then the third biggest one is 5.31 followed by 5.49. Okay? So hopefully that makes sense. This one isn't too bad, so I'm going to go on to the next example. So while erasing the board, feel free to fast forward to the next question so that you don't have to wait. Or if you want to just let it sink in, that's an idea. Okay, so for our next example here, let's say you're given some numbers to add. Okay, I know some of you may think this is basic, but sometimes we forget, especially with a calculator being so readily available on our side. Sometimes you ask Siri and it's faster than having to add these numbers up by hand. So we're going to do it the hard way right now. Okay, so see how many of you can remember how to do that. Better yet, let's see if you can estimate what the sum would be. Okay, so how to estimate okay, just throw a little twist to our question here. The estimate the sum. The sum is the answer to an addition problem. Okay, so step one, you're going to round the first digit of each number. Okay, I don't remember this, that's why I'm writing this down, or that's why I wrote this down. So hopefully you do the same. Okay, round the first digit of each number. I'm going to start writing shorthand here. Like for number, you can just write a number sign if you prefer. Okay. Step two, you would add. Okay, because we're asked to find the sum, so add. Okay. So the first digit of 370 is the 3, right? So 370, the first digit is the 3. So look at the second digit. Is it 5 or more? We would round up to 3. So 370 becomes 400. Okay? The second number is 280. If you have a puzzle look on your face right now, let's do a couple more so that we'll get a hang of this. Okay, so the first digit of each number, this one is a 2. You look at the second digit, the one on the right of this. Since it's 5 or more, are you going to round the 2 up or will it stay the same? Okay, 5 or more, the 2 goes up, becomes a 3. Just like that. Okay, so look at the third number is 410. Okay, so the first digit here is the 4, followed by a 1. Now this time it's less than 5. Since it's less than 5, the 4 stays the same. So we're going to end up with 400. Okay, the last one is 160. 160. The first digit is a 1, followed by a 6. Okay, so 5 or more, again, we round the 1 up. The 1 becomes a 2. Okay, step 2, you would add these 4 numbers up. Add them all up. Okay, you would end up with, let's see, 4 plus 3 is 7, plus 4 is 11, plus 2 is, your final answer should be 1300. Okay, so let's box that out. Piece of cake, right? Let's go on to the next example here. Let me grab a cup of coffee and we'll be right back. Okay, so hopefully you're able to follow along a-okay. It's kind of fun, right? When we break this down into steps for you. Okay, so let's look at the next example here. Since we talked about addition already, let's look at multiplication. So, how to multiply some decimal numbers, okay? So, first series of number will be 8.75 times 28. Okay, equals what? Easier said than done. Especially we haven't seen this for a while, right? Since the elementary school days. So, let's write this down. 8.75 times 28. The key trick is to line up the numbers like so. Push them all to the right side. Okay, we're going to start multiplying from the 8. Okay, so take 8 times 5, you get 40. So, put the 4 on top. 8 times 7, 56 plus 4, 60. Okay, so hopefully your multiplication is pretty smooth. Okay, 8 times 8, 64. Plus 6 is 70, right? Write it down. Okay, so when we go to multiply the 2, remember to put in a placeholder, the 0 here. Okay, before you take 2 times 5 is 10. Put a 1 on top. So that we'll remember to add it to the sum. Okay, so take 2 times 7 is 14 plus 1 is 15. Put the 1 on top. Okay, next. Take 2 times 8 is 16 plus 1 is 17. Just like that. Okay, notice how I line up all these numbers underneath each other so that we can add it without making careless error. Okay, so 0, 0 plus 0, 5 plus 0, 7 plus 7 is 14, so I'm going to carry over the 1 here. 1 plus 1, there you go. Are you done? No, we're not done. We need to find out where the decimal would go. So looking at the number here, 8.75, there are 2 numbers after the decimal, okay, the 7 and the 5. Okay, so in our answer, we need to have 2 numbers after the decimal. Okay, so let's write this down. There are 2 numbers after, 2 digits after the decimal. Okay, let's say digits instead. So in our answer, there's going to be 2 digits after the decimal. See that? Okay, so let's say, therefore, This is an abbreviation for therefore. 3 dots like that. Therefore, there are 2 digits after the decimal. Fun, right? Okay, let's look at another example here. Remember, you can pause and let that sink in. Or if you feel comfortable, let's move on. Okay, so 35 times 6.5 equals what? Okay, so let's lay this out here for you. Take 35 times 6.5. Okay, notice these numbers are lined up pretty nicely. Okay, so we can start multiplying. 5 times 5, 25. Put a 2 on top. 5 times 3 is 15 plus 2 is 17. Write it down. Okay, so remember, again, this is important that you put in a placeholder before we multiply 6 times 5. Okay, so 6 times 5, what do you get? 30. Put a 3 on top. I have the luxury of using 2 colors. If you have a different color pen or color pencils nearby, that would come in handy. Okay, so take 6 times 3 is 18 plus 3 is 21. Okay, now notice how the numbers are neatly lined up. We can add them. 5 plus 0, 7 plus 0, 1 plus 1, and you have 2. Okay, so this is the same as 0 plus 2. Okay, so again, we're not done. We need to find out where the decimal would go. So here, this one doesn't have any decimal, so we can ignore that. But this one does. There's 1 decimal place, 1 decimal value, or you can say 1 digit after the decimal. Okay, so make sure that you have 1 digit after the decimal in your answer. Okay, so our final answer is going to be 227.5. Yay! Okay, so if you want to be technical about this, because these questions give us dollar amounts, so we would want to make sure that in our answer we make it a dollar amount. Okay, so this one is $227.50. Okay, so that now is a picture-perfect example of how we can multiply decimal numbers. Okay, wherever there's multiplication, you know it, you're going to have division. Okay, so let's look at how we can divide decimal numbers. Okay, so let me clear this out first. Okay, give you a minute to catch your breath. I know we're going over like so various types of questions that you might see on your test, final exam, standardized test, whatnot. These are basic skills that you are going to be able to use for the rest of your life. Okay, so how to divide decimal numbers. Okay, so let's look at, for example, 9.85 divided by 2.5 equals what? Right, so how to divide decimal numbers? Okay, this one is a little bit tricky. The way I like to look at it is, I'm going to write it this as a fraction. So I'm going to write this 9.85 divided by 2.5. The fraction bar means divide. Okay? So this tells me that the number that's going to go inside the division box is going to be 9.85. How I knew that is based on this rule here that I always remember, is that the top number falls down to the right into the division box. Okay, so write this down. The top number falls down to the right. Okay, and into your division box. Okay, so now we can start dividing. Before we even start dividing, we need to get rid of this decimal. If you see a decimal in the number here, you need to get rid of it by shifting it to the right until it's gone. Okay, so I shifted one place, one digit to the right. So I'm going to shift the other guy one digit to the right. Okay, now let's start multiplying. 25, ask yourself, how many times can 25 go into 98 without going over? Okay, well, we got there because you know that 25 doesn't go into 9, right? So it's a 0. Okay, that's why you look at this. Two digits here, 98. Okay, I know based on my quarter system that there are 3 quarters in 98 cents without going over. So I'm gonna make that a 3, write down 75. Okay, so 3 quarters is 75 cents, right? You can think of it that way if you like. Okay, so otherwise if I say 4 quarters, that's $1. $1 is more than 98 cents. So that's too much. Okay. Next step is to subtract. 8 minus 5 is 3. 9 minus 7 is 2. Okay? And here I know that is not 25 cents. So I'm on the right track here. Okay. Next step is to bring down the 5. Okay? Ask yourself, how many times can 25 divide into 235 without going over? You can either take a calculator out, do some guesses, but I'm going to think of it as a quarter. So how many quarters can go in $2.35 without going over? So immediately I'll guess 9. I might be wrong, but let's see. Okay, 9 times 5 is 45. 9 times 2 is 18, plus 4 is 22. Okay? So, this, after subtraction, 5 minus 5 is 0, 3 minus 2 is 1. I have 10 left, which is correct because it's less than 25. Okay? So, since I have remainder, I'm going to add in a 0 here and bring it down. Make this 100. Okay? So, hopefully this will give me a good answer without any remainder. Okay? So ask yourself, how many times can 25 go into 100 without going over? So, there are 4 quarters in $1. So I'm going to go with number 4. 25 times 4 is 100. Yay! No remainder. So now the last step is to find out where the decimal would go. Remember, I move it 1 digit to the right, 1 digit to the right, and the decimal would go straight up to in between the 3 and the 9. That's our final answer. is 3.94. Yay! Any question on that? If yes, then please go rewind, take a step back and re-examine this question because this is a little trivial. Okay? So, this will help prepare us for the next question. Again, if it went too fast, feel free to rewind and make sure that you understand how to add, subtract, multiply, and divide decimal numbers. Okay, so now we're going to look at a real life sample question. Let's say if you were to go to a store, or if Joe, let's say Joe or you bought 1.5 pounds of nuts for $7.65. The question is, you probably guess already, how much did he pay per pound? This is good to know so that you know when you go to Smith or Vaughn's or Albertsons, you can make sure that the cashier is not ripping you off. How much did he pay per pound? Okay. Are you going to add, subtract, multiply, or divide? If you guess divide, you are correct. Okay, so let's divide this. What are you going to divide? Are you going to divide 1.5 by 7.65 or 7.65 divided by 1.5? Well, let's look at what the question is asking. Price per pound. Okay, so price is the dollar amount per pound. Okay, so the cost is $7.65, right? Over the pound. He bought 1.5 pound. Okay, so to find out how much he paid per pound, the cost per pound, we have to divide those numbers. Okay, so as mentioned earlier, the top number falls down to the right and go into the division box. 7.65 with 1.5 pound on the outside, like that. Okay, now before I forget, I'm going to move the decimal place one digit to the right. We'll move it one digit to the right. This way we know that in our answer, the decimal is going to be between the 6 and the 5 here. Okay, so ask yourself, how many times can 15 divide into 76? Okay, without going over. Now it's not a quarter anymore, so this will take some intuition. Use a calculator. Okay, I'm gonna think 15 times 2 is 30, 15 times 3 is 45, 15 times 4 is 60, 15 times 5 is 75. Okay, good thing I had my coffee earlier, so my multiplication hopefully is on track here. Okay, so now subtract 6 minus 5, you get 1. 7 minus 7 is 0. So 1 is less than 15. We're on the right track. Okay, next step is bring down the 5. Okay, yay, because 15 goes into 15 perfectly, right? So we're just going to put in a 1 there and say that's 15 with no remainder. Okay, remember we subtract that, 15 minus 15. Okay, so 5.1 is our answer. But let's see. The question asks how much did he pay per pound. So how much is going to be a dollar amount, right? So we're going to say that 5.1. We're just gonna add in a 0 and a dollar sign, and that is our final answer. All right, $5.10 per pound of nuts that Joe bought. Okay. You like that? Pretty fun, right? Okay. If you're able to follow along, give yourself applause on the back here. Be proud of yourself. Trust me, this being patient and writing down the example, writing down the questions, writing down the hints is going to help you in the long run. You'll be able to remember how to do these problems for a very, very long time. So let's look at another real life problem here. If 5 pence costs $8.75, these are fancy pens we're talking about, not the cheap $1 store type of pens here this time. So how much? The question is, how much does each pen cost? Okay, so how much does each pen cost? Probably what I would recommend is for you to ask yourself, are you going to add, subtract, multiply, or divide here? If you say divide, you are correct. So keep writing divide, spelling divide with the E for some reason. There you go, divide. Okay, so we're going to divide the cost. Okay, how much does each pen cost? So total cost divided by the number of pens. Okay, so it costs, the 5 of them cost $8.75. Divided by the number of pens. So for $8.75, you got 5 pens, right? Okay. Now remember, you should remember by now, what number goes into the division box? Okay. The top number, slide down to the right into the box, right? So put it there, 8.75. Okay, 5 is on the outside. There's no decimal number to move. Whatever our answer is our answer. Okay, so take 5 into 8. How many times can 5 divide into 8 without going over? Just once. 8 minus 5 is 3. Okay. The decimal will go straight up, bring down the 7. So how many times can 5 divide into 37? This one I remember. Nope, that's not it. 5 times 7 is 35. Subtract. 7 minus 5 is 2. Bring down the 5. Five divide into 25 how many times? 5 times 5 is 25. Okay, we're lucky again, no remainder. So our final answer, the question asked, how much does each pen cost? So the answer is going to be the dollar amount. So each pen costs $1.75. These are pretty fancy pens here. Okay. And there you go. We just have 2 more questions to look at. We're almost there, guys. You're almost there. So bear with us here. Okay. The next question will ask, what fraction is the smallest? Which of these fractions is the smallest, or you can say the least? Okay, which of these fractions is the little brother? Okay, so out of 2/3, 1/4, 3/5, and 1/6. Which of these 4 fractions is the smallest? So give you a minute to try to figure this out. Let me get a gulp of coffee. Be right back. Okay, the coffee gets me going. So to compare fractions, write this down. I consider this a survival skill when it comes to fraction, okay? To compare fraction, you need common denominators, okay? So you would need a common denominator. Okay, so let's look at what a denominator is. Let me spell this denominator correct first, okay? Don't want to throw you for a loop here. Denominator. There you go. Okay, so what a common denominator, that's the least common multiple, okay? So step 1, okay, find the least common multiple. Bear with me, write this down. Least common multiple you can abbreviate it as least common multiple, LCM, of 3, 4, 5, and 6. Okay, so the quickest way to find the least common multiple is multiply them. 3 times 4 times 5 times 6. Okay, times 4 times 5 times 6. Okay, 3 times 4 is 12. 12 times 5 is 60. 60 times 6 is 36. So 360. Okay, 36. 360. Okay. Step 2 is to find the equivalent of each fraction. This is a little bit lengthy, so good thing I have a little space here on the left. So step 2 is find the equivalent fraction. Equivalent fraction. And you see what we mean here. Okay? So you've got 4 fractions. Let's find the equivalent of these fractions. Okay? So 2/3. Ask yourself, what do we multiply 2/3 by to get a little something over 360? So what do we need to multiply 3 by to get 360? Okay, so 3 times what will give you 360? Okay, so you can take 360 divided by 3, which is 120. Okay, so if we multiply the denominator by 120, the equivalent fraction, we need to multiply the top number, the numerator, by 120. Okay, so 2 times 120 is 240. There you go. Okay, so the equivalent of 2/3 is 240 over 360. So let's find the equivalent of 1/4. Okay, so 1/4, the denominator would need to be 360. So ask yourself, what do we need to multiply 4 by to get 360? Okay, so you can take 360 divided by 4. I'll go to the sheet and say it is 90. So take 1 times 90 is 90. Okay, we're halfway there. So find the equivalent fraction of 3/5. Again, the denominator, they need to be common. So the common number, which is the least common multiple of 3, 4, 5, and 6, happen to be 360. So that is the reason we have that at the bottom. So ask yourself, how many times can 5 go into 360? 72 times. Okay, take 360 divided by 5. So take 3 times 72. Big numbers, so have to be careful, make sure you get them correct. Okay, what's the equivalent fraction of 1/6? How many times can 6 divide into 360? I'll say 60 times. So take 1 times 60. So you get 60 on top. Okay? Now, the way to determine which of these is the smallest is, well, since they all have the same denominator of 360, you can look at the numerator, the top number, and see which of these is the smallest. So 240, 90, 216, and 60. The smallest is this one, right? So the smallest fraction that we have out of those 4 is 1/6. So for your answer, so we can say therefore the smallest fraction given is 1/6. The smallest fraction is 1/6. There it is. That's how we decide which of these 4 guys is the smallest. This is the correct way to do it without guessing. Okay? So don't be lazy. The more of these you do, the more comfortable you'll be at guessing. Okay, later on, once you've gotten the hang of this, you can guess if you like. Okay, and there will be a good chance that your guess will be correct. For now, don't guess. Do it the hard way. No pain, no gain. Okay, so let's look at the last question. Okay, so I saved the best for last. Give it all to you here today. Okay. How to order fractions from least to greatest. Okay. So In other words, how would you put fractions in order from smallest to biggest? Okay. So let's write this down. How to order fractions from least to greatest. Okay, so we need to give you some fractions to work with. Okay, so let's say 1/2, 3/4, 1/5, and 2/3. Which of these is the smallest? Which of these is the biggest? And what two falls in between? So, step 1, same as last time, is you need to find the least common multiple, okay, of those 3, 4 denominators there. So find the least common multiple of 3, 6, 5, and 4. Sorry. Find the least common multiple of 4, 3, 2, and 5. Or you can say 2, 4, 5, and 3. My notes is a little bit goofy for this question. So find the least common multiple of 2, 4, 5, and 3. Which are the denominators here, right? Okay, so the way to do that is to multiply. Okay, so least common multiple equals 2 times 4 times 5 times 3. So least common multiple for this case is 2 times 4 is 8, times 5 is 40, 40 times 3 is 120. Okay? So, step 2, anyone remember from our previous question? You're going to find the equivalent fraction. Equivalent of each fraction okay, before we can put them in order. So 1/2, the least common multiple of these 4 guys was 120, right? So ask yourself, how many times can 2 divide into 120? So what's half of 120? Okay, half of 120 is 60. So take 1 times 60 to get 60. Okay, so the equivalent of 1/2 is 60 over 120. That makes sense because 60 is half of 120. Okay, let's look at the next one. 3/4. Again, LCM is 120. How many times can 4 divide into 120? So that is 30 times. 4 times 30 is 120. So take 3 times 30 is 90. Okay, so that's the equivalent of 3/4. 2 more, we're halfway there. Okay, so be patient and just figure this out. Find the equivalent fraction of 1/5 and 2/3. Okay. How many times can 5 divide into 120? And a sheet. 24 times. Okay. If you don't know these, let's take 120 divided by 5. Okay, so take 1 times 24 is 24. Okay, that's the equivalent fraction of 1/5. Last one. How many times can 3 divide into 120? So this is, I know it's 40. So take 2 times 40. It's 80. Yay. Now, you can put them in order from least to greatest based on the numerator. Okay? So which of the numerator here is the smallest? 60, 90, 24, or 80? Okay, so right away I can see it's 24. Therefore, 1/5 is the smallest fraction. So, therefore, 1/5 is the smallest one. Followed by, looks like 60 is the next one up. So 1/2. Okay. So next one up would be 90. No, it would be 80 here. So 2/3. And with the biggest number here, 90, so the biggest fraction here is 3/4. There you go. We did it the long way, so without having to guess which of these is the smallest, which of these is the biggest, we have proved that 1/5 is the smallest, followed by 1/2, followed by 2/3, followed by 3/4 is the biggest fraction here. Flex your muscle. You've completed the first section. Now please do number 1 to 17. Good luck. You can do it.